How do you balance a chemical equation? In a balanced chemical equation, the number of atoms of an element must be the same on both sides of the reaction. This is because of the law of conservation of mass, which states that mass cannot be created nor destroyed. When balancing chemical equations, you need to count the amount of atoms on both the reactants and product sides, and then add coefficients in front of the elements or compounds to balance them. For example, the equation N2 plus H2 yields NH3 is not balanced. On the reactant side, there are 2 nitrogen atoms because N has a subscript of 2, and there are 2 hydrogen atoms because H also has a subscript of 2. On the product side, you have 1 nitrogen atom because N has no subscript, and 3 hydrogen atoms because H has a subscript of 3. As you can see, 2 nitrogen atoms is not equal to 1 nitrogen atom, and 2 hydrogen atoms is not equal to 3 hydrogen atoms, so the equation is not balanced. We can change the amount of atoms by adding coefficients. We will teach you 2 quick methods to balance chemical equations. Firstly, we will explain how to balance Al plus O2 yields Al2O3 using the table method. In this method, you would use a table to list out the amount of elements you find on each side. On the left side of the table, which is the reactant side, you have 1 aluminum atom and 2 oxygen atoms, and you know this because of their subscripts. On the right side, which is the product side, you have 2 aluminum atoms and 3 oxygen atoms. Again, you know this because of their subscripts. Once you list them out, you need to manipulate the numbers so that they are the same on both sides of the equation. Firstly, look at the amount of oxygen atoms on both sides. The smallest common multiple of 2 and 3 is 6, so you would need 6 oxygen atoms on both sides. Based on that knowledge, you would add a coefficient of 3 in front of the oxygen atom on the reactant side, making it 6 oxygen atoms. This is because 3, the coefficient, is multiplied by 2, the subscript. In your table, you would cross out 2 and write 6 because there are now 6 oxygen atoms. Next, you would write a coefficient of 2 in front of the entire Al2O3 compound. This would not only give you 6 oxygen atoms because 2 times 3 is 6, but it would also give you 4 aluminum atoms because 2 acts as the coefficient of aluminum as well, and 2 times 2 is 4. You would cross out the 3 in the table and write a 6. Now there are 6 oxygen atoms on both sides. You would also cross out the 2 next to the aluminum atom on the product side and write out a 4. The only thing left to balance is the aluminum on the reactant side. You know that the lowest common multiple between 1 and 4 is 4, so you would write a coefficient of 4 in front of the aluminum atom on the reactant side. Cross out the 1 in the table and replace it with 4. The equation is balanced because there are now 4 aluminum atoms on both sides and 6 oxygen atoms on both sides. Secondly, you can balance the equation mentally.
In the equation, COBr3 plus K2S yields CO2S3 plus KBr, we can see that there is 1 cobalt atom on the reactant side and 2 atoms of cobalt on the product side, so we can immediately add a coefficient of 2 in front of COBr3. This means that the cobalt is now balanced because there are 2 cobalt atoms on both sides. Since we added a 2 in front of COBr3, that also changes the amount of bromine atoms to 6 because 2 times 3 is 6. If we want 6 bromine atoms on the product side, we will add a coefficient of 6 in front of KBr. This means that the bromine atoms on each side are now balanced. Not only are there 6 bromine atoms, but there are now 6 potassium atoms on the product side, so we have to go to the potassium on the reactant side and add a coefficient of 3 in front of it, because 3 times 2 is 6, giving it 6 potassium atoms. Finally, there are 3 sulfur atoms on the product side, but since we already added a 3 in front of K2S, there are 3 sulfur atoms on both sides. To double check your work, go through each atom and see if they are balanced on both sides. There are 2 cobalt atoms, 6 bromine atoms, 6 potassium atoms, and 3 sulfur atoms on both the reactant side and the product side. What happens in a more complicated reaction with larger coefficients? Let's use a combustion reaction. Let's balance C5H10 plus O2 yields CO2 plus H2O. Both sides contain carbon atoms, hydrogen atoms, and oxygen atoms. First, list out how many of each atom are on each side. Since there are 5 carbon atoms on the reactant side, we will put a 5 in front of CO2. This changes the amount of carbon atoms to 5 and oxygen atoms to 10, which creates 11 oxygen atoms total on the product side. Hydrogen only occurs in one compound on each side, so we will balance hydrogen next. Since there are 10 hydrogen atoms on the reactant side, we will put a 5 in front of the H2O compound, making the amount of hydrogen atoms 10 on the product side. This also changes the number of oxygen atoms in the H2O compound to 5, making it a total of 15 oxygen atoms on the product side. Next, we need to balance the oxygen atoms. Since there are now 15 oxygen atoms on the product side, on the reactant side we would also need 15 oxygen atoms. There are already 2 oxygen atoms on the reactant side. 15 divided by 2 is 7.5. 7.5 times 2 would be 15, giving it 15 oxygen atoms. For now, write 15 over 2 or 7.5 in front of the oxygen atom. We cannot have fractions or decimals as our coefficients, so we must multiply 7.5 times 2 to give us a whole number. We cannot just multiply one coefficient in the equation, so we have to multiply them all by 2. The 1 in front of the C5H10 becomes 2, the 7.5 in front of the O2 becomes 15, the 5 in front of the CO2 becomes 10, and the 5 in front of the H2O becomes 10. That gives us our final balanced equation. And that's balancing chemical equations explained quickly. Thank you for watching. Make sure to subscribe to our channel for more chem videos. Comment down below any questions you'd like to see answered next.